Advanced Higher Chemists, this one is for you. Let's talk about major and minor products of addition reactions. So let's say we're going to react propene with HCl. When we do this reaction, we will end up with a mixture of two different products. We would make 1 chloropropane and also 2 chloropropane. But the question is, which one do we make more of? I.e., which one is the major product? The major product is actually the 2 chloropropane, and the 1 chloropropane would be the minor product. But why, you may ask? The answer lies in Markovinkov's rule. In Markovinkov's rule, the hydrogen atom will add to the carbon that already has more hydrogens on it. So in this case, this will be this carbon here. This is why this is our major product, where it's got the 3 hydrogens on it at the end, and this is our minor product, because in this one, the hydrogen has added to this carbon, which originally had less hydrogens on it. But this starts to make more sense when we actually look at the proper why and how the Markovinkov's rule ends up coming about. As part of the addition reaction mechanism, we end up forming a carbocation intermediate. The electrons from the double bond of the carbon come out to pick up this hydrogen, which then kicks off the halogen atom. This means that hydrogen will either add to this end carbon here, or it could potentially end up on this carbon here. The carbon on the other side of the double bond then ends up being a carbocation, and these are the key reasons for the major minor product. This carbocation here is more stable because these alkyl groups can stabilise the carbocation's positive charge via the inductive effect, where they push electron density towards the positive charge to stabilise it. In this carbocation here, it's less stable because there are less alkyl groups around the carbocation to provide that inductive effect stability. Hydrogen atoms are not able to stabilise carbocations via the inductive effect because they don't have enough electron density to do so. Our chloride electrophile then ends up attacking that carbocation center in both cases, which then ends up giving us our final product. Because this carbocation intermediate is more stable, there'll be more of these floating around for the nucleophile to attack that carbon centre, which means you're going to get more of the 2 chloropropane, making it our major product. So that is why Markovinkov's rules state that the hydrogen atom attaches to the carbon with more hydrogen atoms attached. Hope that helps. Bye!